Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. As you know, we are learning the chapter on the binomial theorem, and now we are learning how to get a particular term when a condition is given. In our today's session, the same thing, we will be continuing with the same topic. But in our today's session, there will be two binomial expressions instead of a single one. There will be two binomial expressions, and one of them will be raised to the power of 1 and the other will be raised to some positive number. And in the question, there will be the variable raised to some power, and the question will be to get the coefficient of the term in the binomial expansion which contains that variable raised to that power. Is it sounding a bit difficult? Trust me, it will become very easy after you go through this entire video session. So stay tuned till the end and we start with today's session. Okay? The first question, find the coefficient of x to the power of 3 in the expansion of x times 3x minus 2 to the power of 6. Now, there may be students who will be just stopping me and to ask that you had said that there will be two binomial expressions. I am not seeing there are two binomial expressions. I am seeing only there is a single monomial and there is a single binomial. Definitely you are right. There is a single monomial and there is a single binomial. But binomial, what do you mean by a binomial? It is an expression, algebraic expression which contains two terms. And this is having a single term, so it is a monomial. But this monomial can be converted to a binomial. This x can be written as x minus 0 and the power can be thought of as 1. That is why I have said there will be two binomials which will be getting multiplied together, and the power of one of the binomials will be equal to 1 and the other will be getting raised to some positive number. Okay? So let us start with our answer. Now, first of all, let us take up this one because multiplying with x is very easy. Let us take up this part, 3x minus 2 to the power of 6. Because this is the first question and we are totally new to this chapter, so I will be showing you in detail. Okay? So, how can we write this? Using the sigma notation. This will be, our starting value will be equal to 0 and the ending value will be equal to n. And what is the n? What is the value of n for this question? It is the power, which is equal to 6. So, r will be ranging from 0 to 6. And the NCR part, n is equal to 6, so it will be 6 and 6CR. R will be having different values for different terms. E to the power of n minus r, sorry. What is E? E is the first term. So, it is 3x to the power of n minus r, that is 6 minus r. And B is the second term, that is negative 2, and in case you don't understand why am I taking the negative 2 instead of only 2, I would definitely be asking you to go through my previous videos. I am taking up the different chapters one by one which are included in your IB math or AS level or A level math or IGCSE, it may be the extended math or the additional math. When there are some parts, even for IB math, our previous chapter was on arithmetic and geometric sequence and series, and over there you should have noticed, if you have watched those videos of mine, you should have noticed that some parts were from the SL part and some other were from the HL part. So I am just combining all the things that are included in these syllabuses. So I would definitely be asking you to go through all my videos sequentially. I am taking up every topic included in a particular chapter. Okay. So minus 2 raised to the power of r. This is the total binomial expansion, and it will be having 7 terms because n is equal to 6. Therefore, the total number of terms in the binomial expansion will be equal to 7. And all the terms will be getting added together. That is why we are having this sigma notation. For getting the coefficient of the term which will be having x to the power of 3, we do not have to expand this, but since you are new to this type of questions, I am first of all writing the 7 terms separately, and of course I will not be simplifying them, but I am writing the 7 terms separately. Okay. So first will be, and all the terms will be getting multiplied with this x. So let me write x. X will be getting multiplied with each of these 7 terms. So the first one is 6c0 because r is equal to 0. Then 3x raised to the power of 6 minus 0, that is 6, times negative 2 raised to the power of 0 because r is 0, plus second term 6c1, 3x to the power of 6 minus 1, that is 5, and negative 2 raised to the power of 1, plus 6c2, 3x raised to the power of 6 minus 2, that is 4, times negative 2 raised to the power of 2, plus 6c3, 3x raised to the power of 6 minus 3, that is 3, and negative 2 raised to the power of 3, plus 6c4, 3x raised to the power of 6 minus 4, that is 2, and negative 2 raised to the power of 4, plus 6c5, 3x raised to the power of 6 minus 5 is 1, and negative 2 raised to the power of 5, I will be needing one more line. So, plus 6c6, 3x raised to the power of 6 minus 6, that is 0, and negative 2 to the power of 6. Okay. So, this is the end of the binomial expansion. Now, every term will be getting multiplied with this x. The first term is having the power of x as 6. So, x times x to the power of 6 will be x to the power of 7. We need x to the power of 3. So, that cannot be obtained from the first term. For the second term, it is x to the power of 5 when multiplied with x will be giving us x to the power of 6. Coming to the third term, x to the power of 4 times x is x to the power of 5. Fourth term, x to the power of 3 times x is x to the power of 4. Coming to the fifth term, it is x to the power of 2 multiplied by x will be giving us x to the power of 3, which we need. Okay, so this is our required term. This should get multiplied with x to give us the x to the power of 3 factor, and the coefficient will be our required coefficient, will be our answer. Okay. So first of all, because it is the power of 6, therefore I was able to give you all the 7 terms. Had the power been equal to 20, definitely I couldn't have written all the 21 terms. That is why this is not the correct technique. I have written this because you are new. Just to explain, for the explanation purpose, I have written all the terms, and I am showing how are you getting to the x to the power of 3 factor. Okay, then I'll be showing you how to get to the x to the power of 3 using the general term expression. Okay, so now first of all, let us find out what is 6c4, and negative 2 to the power of 4 is 16, and 3 square is 9. Okay, so let us first of all find the coefficient. So this will be equal to 6c4, that is 6 factorial over 4 factorial times 6 minus 4 factorial, that is 2. I have shown you many times how to get 6c4 or NCR using the TI Inspire calculator. This time I have thought of getting it manually. Okay, so, and this is 3x whole square is 9x square times negative 2 raised to the power of 4 is 16, and this is getting multiplied with x. And this is 6, this can be written as 6 times 5 times 4 factorial. And why am I doing this, and how should I be getting the value of this part? If you watch the first video on the binomial theorem chapter, that is, you will be getting the first video from the playlist, you will be having all these things included in the very first video. Okay, that is why I am asking you to just watch every video of mine. I am just going on sequentially. Okay, of course, if you are a student from the SL IB Maths Analysis and Approaches SL, in the binomial theorem chapter, after we complete the power, the positive integer power, we will be moving on to the rational number powers or the negative integer powers. So that part is not included in the SL syllabus, but is included in the HL syllabus. So if you are curious to know something more, you may watch the video or videos rather. But for the HL student, it is a must. Okay, and there is no harm in knowing something more, even if you forget after a time, because you may not be needing that for the SL students. For the HL students, definitely it is a must. Okay, so and 4 factorial and 4 factorial, they will be getting cancelled, and 2 factorial is equal to 2, so I can cancel this. This will be 3, and 3 times 5 is 15, and that will be 3 square is 9, sorry. That will be 9, and then it is negative 2 to the power of 4 was equal to 16. So it is 16, and finally x to the power of 3. So this part will be the coefficient of x to the power of 3. Let us use the calculator to get the value of 15 times 9 times 16. Okay. So 15 times 9 times 16 is equal to 2160. Okay. So it is 2160. 2160 x to the power of 3 is the term, and if you are asked to give the coefficient, you will be giving only this part, that is 2160. This will be your answer, but the way that we have taken is not the correct way, because we can use this method only if the power is a small number. And even if the power is a small number, I have definitely taken some time to write all these 7 terms, which I really do not require. Okay. So now I will be showing you how can you come to this term without expanding the 3x minus 2 raised to the power of 6 totally. Okay. For that, I will be taking this general term 6cr 3x raised to the power of 6 minus r and negative 2 raised to the power of r. Okay. Only this part 6cr negative, not negative, 3x raised to the power of 6 minus r times negative 2 raised to the power of r. So, it is 6cr 3x raised to the power of 6 minus r and negative 2 raised to the power of r. Because I did not keep any space on the left hand side, let me write it on the right hand side, because you know that multiplication is commutative. So 5 times 7 is equal to 7 times 5. So doesn't matter where I am writing the x. X can be written first, or x I am writing over here since I don't have much space on the left hand side. Okay. So, and what do we know? We know that we have to get the power of x as x to the power of 3. So, I just separate the terms. It is 6cr is this, and 3 to the power of 6 minus r, and x to the power of 6 minus r, and negative 2 raised to the power of r times x to the power of 1. So, this x to the power of 6 minus r is getting multiplied with x to the power of 1. So, the final power of x is x to the power of 6 minus r plus 1. Okay. So, this 6 minus r plus 1 should get equated to 3. And then you get the value of r as 6 plus 1 is 7, 7 minus 3 is equal to 4. Okay. R is equal to 4. You see the term that we have taken for this term, the R value is equal to 4. This is how you have to know the R value. You cannot just afford to get all the terms of the binomial expansion. Okay. So, you just write, you always start with the general term, and 3, I have just separated the coefficient and the variable. 3 raised to the power of 6 minus r and x raised to the power of 6 minus r times negative 2 raised to the power of r times x to the power of 1. So, these two, if multiplied together, will be giving us the power of x, final power of x as 6 minus r plus 1. So, I equate this expression 6 minus r plus 1 to 3, which we had done in our previous video also, when we were required to get the coefficient of the term where the power of the variable was given. So, 6 minus r plus 1 equal to 3 gives us the r value as 4. As soon as we know the r value to be equal to 4, we can just get 6c4, 3 raised to the power of 6 minus 4, that is 2, x raised to the power of 6 minus 4, that is 2, and minus 2 raised to the power of 4, and x to the power of 1. X to the power of 2 times x to the power of 1 will be giving us x cube, or x raised to the power of 3, and 3 square will be 9, and negative 2 whole raised to the power of 4 will be 16, and 6c4 we have seen that to be equal to 15. Okay, so 2160 is the coefficient of the term containing x to the power of 3. This is our answer for our question number 1 or first question of this session. Let us move on to the next question. So the second question says, find the coefficient of x to the power of 5 in the expansion of x plus 2 times x square plus 1 raised to the power of 8. So now let us start with our answer. As we have done in the first question, we will be taking up this binomial expansion part first. So it is x square plus 1 raised to the power of 8. What is the value of n? N is equal to 8. A is equal to x square. B equal to 1. And we do not know what is the value of r. We have to find the value of r. So we start with the general term. Since it is x square plus 1 raised to the power of 8, we know that if we expand this, there will be a total of 9 terms, right? And these 9 terms will be getting multiplied with x first and then with 2. Like if you have, say, x plus 2 and if you have, say, x square plus 2x plus 1. So this is a set of 3 terms. First of all, these 3 terms will get multiplied by x and we will be getting 3 products, and then these 3 will be getting multiplied again by 2. So we will be getting another set of 3 terms. Similarly over here, this expansion will be having 9 terms. So all those 9 terms will get first multiplied with x to give us a set of 9 terms, and then by 2 to give us a new set of 9 terms. And all those will be getting added together. Same over here, like when we multiply all these 3 terms by x, the terms that we get, let me write the terms. X times x square is x cube plus 2x square plus x, and then 2, I am writing this is the plus sign that I am giving, 2 times x square plus 4x plus 2. So all these terms are getting added together. Okay, so over here also, when we are multiplying this x with all the 9 terms, the 9 terms that we are getting, those will get multiplied with the 9 terms that we are getting when 2 is getting multiplied with these 9 terms. Okay, and of course we will be adding the like terms and simplifying. That will be the simplified form of the expression, but we are not interested in getting such a long expression. We do not have that time, we do not have that intention, we do not have that energy, and we are not required to get that. Okay, so we will not be doing that. We just want to get the coefficient of the term which will be having this x to the power of 5. So first of all, let us take the general term, that is 8CR e raised to the power of n minus r. E in this case is equal to x square raised to the power of 8 minus r, and b raised to the power of r. B is equal to 1 raised to the power of r. 1 raised to anything is 1. So I will not be writing this part anymore. I am being able to skip this part because it is a 1. Had it been some other number, obviously I would have been forced to keep it, definitely, but since it is a 1, I am just ignoring it. So it is 8CR times x to the power of, if I simplify the power expression, it is 16 minus 2R. Okay, so this is the general term expression. This should get multiplied with x. Every term will be getting multiplied with x. So R will be, starting value will be equal to 0 and the ending value of R will be equal to 8. I am taking, out of those 9 terms, I am taking one general term and I am multiplying that with x. So x times 8CR x to the power of times x to the power of 16 minus 2R. So this is x to the power of 1. Therefore, what is the final power expression for x? It is x to the power of 16 minus 2R plus 1. Okay? And this should be equal to the number 5. So 16 minus 2R plus 1 should be equal to 1. Sorry, not 1 but 5, because it is 5. So 2R is equal to 16 plus 1 is 17. 17 minus 5 is 12. Therefore, R is equal to 6. We have found the value of R as 6 when x is getting multiplied with this binomial expansion. Not when 2 is getting multiplied with the binomial expansion. We have not come to this part yet. Okay? So, now that we know about the value of R, we just substitute. It is 8C6 and x to the power of, obviously, 16 minus 2 times 6 is 12. 16 minus 12 is 4. 4 plus 1 is 5. So, it is x to the power of 5. And what is 8C6? 8 factorial over 6 factorial times 8 minus 6, that is 2 factorial. So, this is times x to the power of 5. That is equal to 8 times 7 times 6 factorial over 6 factorial, and 2 factorial is 2. So, this is x to the power of 5, which is equal to 28 x to the power of 5. And they are asking about the coefficient. Okay, fine. This is the term which contains x to the power of 5. We are not done. We have to multiply with 2 as well. So, again we will be taking the general term and in place of x we will be writing 2. Okay. So, it is 2 times 8CR times x to the power of 16 minus 2R. And 2 is not having any x, so the final power expression of x is 16 minus 2R. And 16 minus 2R should be equal to 5. So, 2R is equal to 16 minus 5, which is equal to 2R equal to 11. Or R equal to 11 over 2, that is 5.5. R cannot be a fraction or a decimal number. The smallest value of R is equal to 0 and the highest value of R is equal to n. In our case, 8. And R increases in steps of 1. 0, 1, 2, 3, 4, it goes on. R cannot have a decimal number or fraction value. Therefore, every term in the expansion when getting multiplied with 2 will not be giving us any term containing x to the power of 5. Had it given a term containing x to the power of 5, these two would have got added because these two would have been like terms. Both would have had x to the power of 5, and we would have added these two, and the final number, the final coefficient would have been the answer. But since we do not have any term from this part which will be having x to the power of 5, therefore our answer will be just this part, 28. And if you are not sure about whether at all we will be having a power of x as 5 from this part, let me show you. Okay. As I have said, our starting value is equal to 0 and the ending value is equal to 8. This part does not contribute to the power of x. I am just getting the powers of x by just substituting different values of r when r is equal to 0. 16 minus 2 times 0 is equal to 16. R is equal to 1. 16 minus 2 times 1 is equal to 14. R equal to 2. 16 minus 2 times 2, that is 4. 16 minus 4 is equal to 12. R equal to 3. 16 minus 2 times 3, that is 16 minus 6, which is equal to 10. Okay. I have done 2 times 1, 16 minus 2 times, 2 times 0, 16 minus 2 times 0, 16 minus 2 times 1, 16 minus 2 times 2, 16 minus 2 times 3. I can go up to 16 minus 2 times 8, that is 16 minus 16, it will be equal to 0. But every time you are seeing the power of x is an even number, we will never be getting an odd power of x, because 16 is an even number and 2 multiplied with any number gives us an even number. When we are subtracting two even numbers, the answer will be another even number. So we cannot get x to the power of 5 from this part. That is why we are not getting any expression or any term containing x to the power of 5 from this part. If we had one term containing x to the power of 5 from this part, this would have been, suppose this is the term, we would have added this to that and the final coefficient would have been our answer. But since we are not having any term from this part, the answer, the final answer, the coefficient, the coefficient of x to the power of 5 is 28. Okay. So this is our answer for this question. So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you found the video helpful. So bye for now.